Yo, welcome back to the channel. It's your boy Street Coder Nate, and today I got a fun one for y'all. Today we tapping into what is coding. I get a lot of people asking me on a daily, like, bro, what is coding? You always talk about that people need to go learn what coding is. So, like, what is it, bro? Like, what is it? So, at this point, I'm finna explain it to y'all. So, come on, let's tap in and let's get to what is coding. So I like to always start with asking somebody, what do you use technology for, right? So what do you use technology for? And so people will say, I use technology, to communicate through text, like I text to people. I use technology to see people, and like you think social media. I use technology to pay my bills, and so it just all these things. And so it's just typically surface level things that they say that they're using technology for. So then I tell them, go deeper. What does that mean? Like, what does that mean that you're using technology to do these things, right? What does that mean? And so they're like, what you mean? What does that mean? Like, and so I'm like, let me take you on a journey back in the day where technology, let's say, was first introduced. Let's take fire, for example, right? So fire is the technology. And so before you had, let's say, these Neanderthals or cavemen who didn't know how to initiate fire. And by the way, I got a shake today. Make sure y'all got something to drink. Tap in. Listen, this one is only going to be about what is coding. No, not coding. Won't be no coding video. I'm just explaining what coding is. So we say two Neanderthals, cavemen. Well, they chilling, and let's say one day these they're let's say they're boxing, right? They're feuding with each other because humans, that's what we do. We just feud, regardless if we was Neanderthals and regular humans. Now we always feuding, and so let's say they stayed on different sides of the lake or whatnot. But then when they crossed the lake, they always fought and whatnot. One day, one one day, let's say one of the Neanderthals figures out how to take two sticks on accident, and he like just playing around, and fire comes, right? So now this man's like, oh nigga, I know how to initiate fire, my dog. So next time bro come over from across the lake, now you got bro saying, hey, let's box. And next thing you know, you got a man like he like brought his fist to a firefight for real. He brought his fist to a firefight, and obviously, bro gonna be like, whoa, how'd you do that? Because he's never seen someone just ignite fire like that out of nowhere, and so obviously scares him. Technology was that fire. What did fire do for us in that point? Remember, I said, like, so what we did here was use technology to protect ourselves. So now I'm asking, let's go deeper. What is that actually doing? Technology, well, before we was using our fists to protect ourselves, right? Whenever bro came from across the road, we used our fists. We said, all right, we boxing. But then we figured out that we could take these two sticks, simple, two sticks, rub them together, and have some fire. What fire basically did was extend the power of the fist. It extended the power of the fist. The fist had already had a lot of power in it when they was boxing. But now with the invention of fire, the fist became way more powerful. I didn't even have to use my fist anymore. I just ignite the fire and I could scare bro. And if bro not scared, then I could put the fire on him and burn him. Definitely a way to extend my fist. And instead of saying extend my fist, that's just a specific example. There are different technologies all around the world that extend different human capabilities. And that's basically what technology is. It helps us extend our human capabilities. So let's move forward back into time where I'm asking y'all, what do you use social media for? What do you use texting for? What do you use a car for? Well, let's try social media. With social media, we see our friends, we see our family. All of this. Social media literally closed the distance closed the physical distance that we have between each other, and showed us that we're all like connected together under one network. And so there's never no separation. So if I ever wanted to see your face, I just go to your social media pages and I'll see your face. I don't have to go travel miles as people did back in the day. So social media right now is extending our way of communicating. It's extending our way of commiseration of being together with people. Is that's what social media is doing. And so now you take, like, let's look at texting. What is texting? Well, texting and talking on the phone, that's helping us extend our voice across a distance. Now we, like two physical beings far apart, can speak to each other as if they're like right next to each other. And technology is helping us extend our voices along the distance. And you see what I'm saying, like technology is used to extend human capabilities. Technology isn't doing anything that humans could not do. Technology is not doing anything that you couldn't do. And the thing is, the reason we put so much emphasis on technology, the reason we put so much importance on technology is because technology, my bad, I had to put that on Do Not Disturb, is that because technology is not like a human. A human got emotions, a human got distractions, it got all these different things. Technology ain't got none like that. It just got process, 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 process. And after it's done processing, it rests. And then when it's not resting, it's processing. And then when it is resting, it's resting. You think about a human, our brains run 24/7, process, 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 process. The only time we stop processing is honestly when we asleep. And not even when we watch a TV or listen to music. You probably think you're not processing, but you're processing. And so our brains get tired after processing so much. So the thing is, we take the tedious tasks, we take the tasks that we don't really want to do, or we take the hard ones and we push it off to a computer, and we tell the computer to do that task, right? Well, let's take this idea of telling the computer to do a task for us, right? Like, what's one of the tasks that you could tell a computer to do? Well, or technology to do. Well, you could tell technology to send a message for you, right? And so you can tell the technology, let's say a phone, and then your friend has a phone. So you're gonna tell your phone to send this message to your friend. Cool. All right, let's remove the phone, right? Let's remove the phone. Let's add a human in between. Like, so instead of having two phones, there's just a human entity that travels back and forth, and we tell the message to the human. The human then takes our message and goes to the next person, tells the next person the message, picks up the next person's message, brings it back to me, and I'll hear the message from that person. Then I go explain you see, going back and forth. We're using a human, and we're basically telling a human what to do. Hey, take this message. What is the message? This is the message. Take this, deliver it to this person. Where does that person live? Well, this person lives right here. So then we take that person takes the message and then deliver it the way they deliver it. He reads it out or says it out to the person. Person hears it. Okay, here's another message. Take this back to the person that you just got it from. Right. So that's what our phones are doing naturally. Our phones are. I'm telling. Well, before the phones. So I'm telling a person to do that for me. And you kind of think about a mailman. That's basically, I just described a mailman. So I'm basically telling the person to do that for me. Now, I have to instruct the person on every move where the person that I want to message at, what the message is, and like all those things. And so I have to write that out step by step. Now the thing I don't have to write out is how to get that message to the person. Like the human, it kind of knows that it's probably gonna take Google Maps, or probably already know where the person lives. So I don't have to explain a route to take. Now, I use the person there, but let's take that person and let's go back and replace it with technology, right? So with technology, let's say we were creating a messaging app. What we would have to do with the technology is literally tell that application line by line by line what to do. Instructions. We're giving the technology instructions. Take this message, package it up, however you send it. But the thing is, I can't say however you send it. Because the computer isn't like a human. It doesn't have that intuition. It doesn't have all that background knowledge that humans do. Maybe now with machine learning and big data and whatnot, but before it didn't have all that background knowledge and intuition. Therefore, you had to tell the computer literally every step what to do until it finishes the processing, until it gets a result that you want, right? And so You gotta tell the computer, take this message, and you gotta say, break this message up into bytes, right? And then you gotta say, in each byte, package this message up like this, put some metadata on it, and then send it to it literally have to write instruction by instruction by instruction by instruction by instruction. Every single thing that we do in this world, we have to write instruction by instruction by instruction when it comes to technology, right? So if we write an instruction by instruction by instruction, if that's what we're doing, then what is coding, right? Well, you guessed it. Coding is just writing instructions for a computer to understand. What are those instructions doing? Those instructions are we're instructing the computer to do something for us, the human, that we could have done ourselves. But the computer, once again, is more efficient. So we learn how to talk to the computer, so therefore that we can instruct it to do what we want to do. Well, how do we talk to computers? Well, the computers don't understand English. There's just too many languages, right? You have computer and you have human. These are two different entities, but within human you have multiple languages. And so in technology, it's kind of like just the same. Like, it's different technology here and there, yeah, but like they all communicate the same. They use the same language to communicate, right? Or typically zeros and ones, and that's what I'm introducing. So with English, and with humans you got English, French, and all the other ones, right? And so the computer is not about to learn every single language so that each language can program, or so that each language can communicate with it, so that each language can write code to tell it what to do. The computer not about to do that. So what the computer does, though, it says, I have a language, my family of people, all technology, we got this language. It's a common language because it works. 0 and 1. It's only 2 digits. Now you think about our language, 26. You think about all the different languages out here that got like characters and stuff that be like hundreds of thousands of characters. That's a lot, right? So basically, what's happening is, we, instead of telling the computer to take all these languages and learn them, we tell the computer just take one language and then translate, or learn one language, and now with your language translate to any other language. Humans are going to translate our language to your language so that you can understand us. So we're going to give you a language, and so what is that language? And so that language became zeros and ones, and that's called binary, right? And so zeros and ones were really cool because the thing about zeros and ones is that you could do something like this. Like, you could take zeros and ones and then you could start mapping stuff. And you see how right here I pretty much mapped this. I mapped 0, 0, 1, and I set it equal to A. So in a computer, if a computer ever saw 0, 0, 1 as I was programming, it would see the letter A. And if it ever saw 0, 0, 0, 1, 1, it would see the letter B right here. And so what I typically try to do is or not typically try to do. So in an example, let's say we were trying to code to the computer and write the phrase AB, right? The way that we write the phrase AB is say 0, 0, 1 with a little space in between 0, 1, 1, and the computer will read that up as AB, two different letters. And so you can think, if it was a different language, let's say 0, 0, 1 equals let's say a Chinese character or something. I don't know how to write Chinese characters. But now the computer, if it said the language is Chinese, I don't know how to spell that either. It reads 0, 0, 1 and now it sees a Chinese character. But if the language is English and it reads 0, 0, 1, then it's going to read an A. So now the computer doesn't have to learn each one of these. It just knows the mapping in between, right? And the thing is, it's not the computer that knows, it's the programmer. The programmer knows that this translates to this. So now what we used to do as programmers when we wanted to communicate to our computers and tell our computers what to do, we had to write literally zeros and ones. We would create like whole programs full of zeros and ones and then feed this program to some like machine called a computer at the time. And we fed it to the machine, and the machine will process it and then give us some output, most likely in terms of zeros and ones or in something that we can understand as humans. So that's the output. So that was pretty much the beginning of programming. That's the beginning of coding. That's how we started coding. That is what coding is, like writing these zeros and ones so that the computer can understand what we're trying to do. Well, the thing about zeros and ones is that zeros and ones become very, very complicated when you have hundreds of thousands and millions of lines of code. That's almost impossible to look at zeros and ones and be like, I know exactly what's going on, right? So what happened is, instead of saying I know, instead of continue writing zeros and ones, there were some programmers who took who took the zeros and ones type of mapping and created a different language. And so this language was called assembly language. And the thing is, the assembly language allowed us to use more human readable words to communicate with the computer, because zeros and ones is really hard for a human to read. We were able to use more human readable words. But the thing is, once again, the computer doesn't understand the human readable words. We need to feed the computer zeros and ones. Therefore, what we decided to do was create this thing called a compiler, called a translator. And basically what it does is we wrote code, let's say move 1 1 join 2 3. This is an example kind of like of what the assembly language looked like. And we took this assembly language, and the thing is, we mapped, let's say this line, we map, let's say move is equal to that, 1 is equal to that, and then 1 is equal to that. So now the computer, when it sees move 1 1, really saying is 0 0 1. Oh wait, I can't make move equal to that one. Or no, what it's seeing, that's a 1. What it's seeing is 1 0 0 for move, and then it got the 0 0 1, and then it got another 0 0 1. So this is the instruction that then gets given to the computer. So basically, we take this and we translate it, we compile it to something that the computer can understand. Then, now that the computer can understand that, we give it to the computer, and the computer then gives us our output. That was assembly language. And assembly language was real cool at the time, right? Like, can't really get mad at assembly language. It was dope at the time. Like, we went from writing zeros and ones right here to now writing human readable words. The only thing about assembly language, though, is that, like, assembly language was really, like, playing with, like it really got very, very to the low level. And so remember how I said you have to tell the computer literally everything to do. Well, you have to tell the computer, not only did you have to tell the computer, like, send this message, but you got to tell the computer how to store that message, where to retrieve that message from, and the information for that message. Like, you have to tell the computer every single thing. And so one of those things that you had to tell a computer to do was, like, let's say, one of the natural things to tell a computer to do is move information from one place to another place, and then add information and then store it back in different places. Well, you can kind of let's get back to my screen. Well, you can kind of think of a computer for real as a human. Like, the humans, we really do that too. And you kind of got to think about when we're participating in different activities, we're taking memories, we're taking data from past events, and we're taking that data from our long-term memory that, let's say I haven't played basketball in 2 months, 3 months maybe. So that basketball knowledge, how to work and whatnot, that's stored somewhere in my long-term memory because I haven't used it in a while. But as soon as I go on the court and whatnot, my brain is going to do a natural thing, which is go to my long-term memory and bring back the different skills that I know and store it into my short-term memory so that I can easily access it when I need it. My short-term memory is something that can be used like if I need it real quick. It's for the activity that you're using right now. And so the computer is kind of set up the same way. It's like it got this thing called a CPU, and then it got this thing over here. We call this a CPU, and then we got this thing over here called the RAM, and that's just this. And then we got another thing right here, and that's this. Let's call this your hard drive / SSD. Okay. So, well, when I say short-term memory, well, that's your RAM. So this is your short term, right? And then this is your long-term memory right here. And the thing that's moving data back and forth, or that's moving our memories from here to here, is our central processing unit. We as humans have a central processing unit as well. We think our brain is a central processing unit, but we there's different facilities inside of our brain that do processing for us, right? And so we'll just call this one the brain though. But you understand though that the brain, you kind of think about the Apple M1 chip, it's kind of set up like this, like a human brain in a way. Like the RAM is on the chip, and it's like integrated. It's the integrated RAM, integrated hard drive, and the CPU. It's kind of crazy when I think about it. But yeah. So you tell the CPU. So the thing is, remember I was saying we would be writing instructions, right? We're writing instructions right here, and we're feeding those instructions to our program. Well, the thing that we're feeding the instructions to is the brain. And then when you think about a human, you talk to a human, you are feeding instructions to a human technically, but what's picking up those instructions? It's brain, and it's processing those instructions and doing things after that. So let's say this move, let's say there was a 1 here and 1 here and some data that was, let's say 1 0. So let's see, I see this move command, and let's say move means the computer understands move to be take this value right here from RAM and move it to this location, and take that value, or let me see, take this location in memory in your SSD, your hard drive, and take the data from there and move it to the data here. So let's say that this was address 1 and this is address 1. Basically what I'm saying is CPU move this data to here, 1 0. And so we have to write each one of these steps. And so when you think of those data, you can think of that data as, let's say this is my basketball. So I'm saying, CPU, I'm about to go play basketball. Or in my brain, I'm thinking, I'm about to go play basketball. Well, my CPU naturally does, because God programmed us before. God programmed us. So what our CPU naturally do is go to our long-term memory, pull that basketball data out, and store it in our short-term memory. Well, with assembly language, we have to tell the CPU to go to the long-term memory and store things into the short-term memory, take things from the short-term memory, store things into the long-term memory, or take things from the short-term memory, start processing it. So now that I got now I got the skills how to play basketball in my short-term memory. Now I'm like, okay, somebody's defending me. I'm processing. So now I'm processing, and then I'm just taking different skills from where I loaded all these skills here, right? So now I'm just taking different skills, and I'm trying them out and doing different things as I'm processing what's going on right in front of me. That's what the computer is doing. As the computer is processing, it's moving data from your RAM, or from your it's moving data from the it's moving data that way. So it's moving data from the SSD. The more I go that way, there we go. It's moving data from the SSD to the RAM. And so you got your CPU that's doing that, so moving it from the long-term memory to the short-term memory. And the thing about that is we do that naturally because God programmed us. And if you check out the title, or check out the the quote that I have, that God created man and in His image, and man is creating computers in our image, is basically exactly what we're doing. Like we see in the way that we process things as humans, we understand how humans process things, and we just gave that same logic to computers, right? And so now, because computers can process things how we process them, we can communicate back and forth. And so one of the languages that we used to communicate was assembly language. But not too many people want to say move, like when and think about it, when you are hooping, you're not saying give me that one skill so I can do the crossover real quick. You just saying crossover. But what's happening is that your brain, as you see that person right in front of you, your brain is processing ridiculously fast that you need to do that crossover. So it's going to your short-term memory and grabbing that do the crossover move, and it performs the do the crossover. That's what the CPU is doing. Literally. That's what the CPU is doing. But the thing is, or the computer is doing. The thing is, like, we don't have to tell our brain move or go to my short-term memory and grab that crossover move so I can hit it and then perform it. We just naturally perform that crossover, right? And so scientists or computer scientists was on that same tip when it came to coding. It was like, we don't want to have to tell the computer. We know that that's what it's doing, but we don't want to have to tell it to do that. We want it to do that subconsciously, right? And so what people did was they took the assembly language. And so remember, they already took zeros and ones and created assembly language. Well, then now they took assembly language and formed it all together and created this language called C. And so C was basically that do the crossover without doing the crossover. But if I needed to, say, store this information at this place or in this place in memory and in RAM, C allowed me to do that, but I didn't have to use that if I didn't want to. And so that was real dope, because like programmers was like, bet I can use English, I can understand what I'm saying, it's not too hard, I don't have to deal with the processor if I don't want to. The thing is, you were still dealing with bits and memory and all of that, but it's just like you was allocating memory, and the amount of memory was C, but you weren't like telling the computer to move the bits and whatnot, right? Cool. So now, so we got C, and C was processing. It's called a functional language, because you if you think about it, you give it a function, you give a function input, and then it give you some output. So with a computer, typically we giving it some input. With a phone, what's the input? Our voice, and the output is someone else's voice coming back, right? And so that's when you think of computers, that's basically what it is: input, output. And so and then just different processing. So I give it my voice, it processing is running different commands to do things. So what is it going to do if I give my phone my voice? I give my phone my voice, it takes my voice, it packages it up, it sends it over the network to the next person's phone, unpackages it, then reveals my voice to that person, right? That's what the technology would do. And you could do that functionally, like you just input, output. But the thing is, as computers computers got smarter and technology got smarter, we wanted to start, humans was like, what if we can represent the real world in our brain, right? We can think about a house, we can think about a house in our brain. Like, the world has different objects around it. It has like tree objects, house objects, car objects, like people objects, right? And so the world has all these different objects, and our brain is able to take these different objects and store them logically in our brain and make sense of them. Well, we wanted to do the exact same thing to this brain right here as well. And so, but C didn't allow us to do that, right? C just was like, this is just functional, like take some information, process it, give me some output. Well, now we took C and we added some more on it, took some salt, some pepper, maybe even some seasoned salt, some red hot, mixed it together, and we got C++. C++. And not now, C++, that's the first language I learned, but C++ allows us now to store different objects, to create different objects in our we can store different objects in our brain, in our hard drive, in our long-term memory, and we could retrieve those objects and place them into our short-term memory, and we can interact with those objects. Think about it, memories. Like, just you're getting where I'm getting at. So we can interact with those objects. We're gonna get deeper into it in another video, but you can interact with those objects, right? And so C++ allowed us to do that, and C++ was real cold though, because it still allowed us to hit like some of the lower level things. And when I say lower level, I'm thinking lower level languages. I'm thinking things that are closer to zeros and ones. Remember, zeros and ones is the closest you're getting when communicating to computers. And then then the levels get higher. It get higher up. Remember, assembly, C. Now we have C++. C++ was real cool because it's still technically like, it's like a middle level language. It's not like a higher level or a lower level. It's like a middle one, because you still can do the things that you do with the higher level languages like Python and Java, and we're gonna get there in a second. But you also still have the ability to mess with memory, like allocate memory and the RAM and the system calls and all of those. So C++ was real dope for that. But then people was like, I don't really care about allocated memory. Like, if I say I want this object created, I don't want to tell my brain I need to allocate this much space in my brain to take up space for an object. Well, in C you had to do that. But now in languages like Java and JavaScript, or in Java and Python, they built up off of C++. And now they got these they don't have to worry about telling your brain to allocate space. You just tell your brain, hey, I got an object I need to store, and the brain just takes that, and the CPU would just take that object and then just store it in the brain somewhere. It allocates the space for us, it remembers where it is, but we don't have to do that, and we don't have to remember that ourselves. And so now it's like, okay, well, I got the CPU, and I got objects, and I got higher level languages where I don't have to use that abstraction. Well, what's the point of computer science? Well, we just explained it, right? So we wanted to learn how to communicate with our computers, right? We needed to understand, how do we give these instructions to computers? And so through pretty much through figuring out that computers understand zeros and ones, and figuring out how us humans can translate to zeros and ones, we now can give these instructions to the computers. But the thing about zeros and ones is, let me get back here real quick. The thing about zeros and ones is, it has its own, let's say, rules to the language. These are rules, and another way for say rules is syntax. This is the language syntax. These are the rules of the language. In order for the computer to understand this, I have to follow a specific pattern. And if you think about English, we have a specific pattern that we follow when we creating words and different things and sentences. So it's the same exact thing when it comes to coding languages. And so this is the zeros and ones coding language, and you got assembly right here. And assembly has its own syntax, and so if I wanted to communicate with a computer using assembly, I need to write in assembly syntax. And if I wanted to communicate with the computer using C++, C, Java / Python, I have to use those syntaxes. And so the reason I bring up syntax is because that's how we communicate with computers. If you were English and you're trying to communicate with a Chinese person, you would not use English tactics to communicate with that Chinese person. You just wouldn't get done what you were trying to get done, right? You typically we communicate for another person to do something for us so that they can understand us. And the thing is, if we can't communicate properly with that other person, they can't do that for us, nor can they understand us. It's literally the same exact thing with computers. You have to follow that syntax. You can't write C++ code and then try to give it to something that understands Java, because that's just two different languages. And at the same time, you can't write C++ code the way that you want to write C++ code and then try to give it to a computer that understands C++ code and like, no, this is not right. Like, you kind of think about slang and English and whatnot. Like, we got our own variations to English, and it's different though, But yeah, it's kind of like that. It's like some things you can understand, other things you can't, depending on like the slang I use. And so that makes sense. If I say I'm on that tip, y'all be like, what the hell that mean? You feel me? And so, but it's still English. And so you could do the same thing with C++, is right, C++ code, but you can use different syntax, incorrect syntax, and it won't communicate effectively. And so that's pretty much why we're coding, right? The reason we're coding is to communicate. We're trying to communicate to our, oh, that's a little space thing. Let me go back over here. We're trying to communicate to our basically we're trying to communicate to our computer what to do for us. And so the way that we communicate to our computers was first through zeros and ones. Now we write our commands with different higher level languages like C++, Python, Java. And on this channel, I was introducing y'all to JavaScript in the last video. And in the next video, we're going to get right back into it. Just have to explain some programming stuff. But yeah, you understand the purpose of coding. That coding is just, well, first, that technology is just an extension of the human being, and that we code to explain to that technology what we want it to do for us. Just as we tell a human what to do for us, we need to explain to the technology the exact same way. Make sense? Dope. So cool. Now you understand purpose of coding. You understand why we code. So now we're gonna hop back into JavaScript and go to variables. Remember, storing variables help us store data. And you go back to that model that I have right here of RAM and CPU and whatnot. And I'm talking about data. Memory is just data. So RAM or the CPU is helping us store data. What I mean by that, we are going to see very, very, very soon. What do I mean by that? The CPU is helping us store data. But until then, I'm going to get with y'all. We about to be out of here. Remember, drop a like, subscribe, get with your boy. Peace.